Hi, welcome back to CMG-MathSpace. Now, still continuing on our series on the properties of set operations representation in the Venn diagram, we are going to look at a special property or a special law called De Morgan's laws. Now, these laws will encompass the complements and the union and intersection and everything. I mean, the rest of the episode that I talked about, this will cover everything. So stay tuned. Now, like we do always, we always like to give you some preambles, some notes to take home or to guide you in solving these questions easily. First one, let's look at, before we actually look at the De Morgan's law, right? The De Morgan's law, let's first have a look at these properties or these properties. Now, if you remember, I told you there's a difference between let's say only A only and then A complement. There's a difference. Notwithstanding, one can be expressed in terms of the other, but it will be interesting or helpful if you know the difference between these two. So I have taken notes. These are the notes that I have prepared out of the understanding or the concepts. Now, the first one, we are looking at drawing the difference between complements and then the onlys, right? Now, let's say for onlys, example A only. How do we do this? When we say A only, what we are requiring or expecting from you is to shade everything in the left side except the set or the items in U and the other sets, right? I think there was a repetition here, a redundancy here, right? Other sets. That is for you or only. So if I say shade A only, it is different from shading A complements. Get that right. So for A only, what is the preamble or what is the note that you have to take care of or understand? We mean that shade everything in the left side. I will express this in the left side and then the right side. I could actually be using the set, but for literal meaning understanding, I told you we are dealing with we are dealing with the literal expressions of the problem, right? So only. Now let's look at for complements. Assuming we have been asked to find the complement or the shade the complement area. So what does it mean? We mean that we are shading everything in U and other sets except A. Check it very carefully. For the only, we are shading everything in the left side except the U and other sets. And then for complement, we are shading everything in U and other sets except A. Let's see this practically. So look here. We are taking two intersecting sets. So if U is a universal set and A and B are two intersecting subsets of the universal set, then figure 1.11 shows how to illustrate or represent the sets A and B in a Venn diagram. So we were talking about the left side and right side. That's why I'm doing this. So there are four regions. So A intersection B. What does it mean? Element belonging to A only. So you see, it has been expressed in another form. A, that's element belonging to A only, or only A. Region 2 is A, intersection B. That one is very simple. I'm not going to worry myself. My concern is with a complement. Now, region 3, don't worry, we'll see the diagram. A complement intersection B. What does it mean? Literally, it means that element belonging to only B, right? Now, region 4, into A union B or complement, elements belonging to neither A nor B. Let's see them. So for the top here, let me bring it down a bit. Top here, this one is simple. That will be A intersection B. It's simple. And my concern is with the complement. So now let's come here. A intersection B complement. We told you anytime there's a complement, we deal with the complement first, right? But here, it means that we are dealing with only what? We are looking at A only, right? A only. This is it. This expression of A only. This is how it's expressed. Take note. So if A only, we are talking about what? The shading only the left side. So the left side is only this part. Because we have left side, right side, and you have the intersection. So me or I saying left and right, or the intersection, the left side is A only. That's A only this portion. So the same thing, if you understood that, the same thing is for B only, which is expressed this way. B only, which is expressed this way. Whatever we read at the back of the page, this is practically in what? In Venn diagram. So this is this. So this is what? If it's A only, this is B only, then we have what? A complement intersection B complement. This can be expressed in this form. So we are taking A union B, and then the complement. The complement means shading everything except that expression. So we have here, that is the union. We are adding all of them. But we are looking for the complement, meaning we are shading everything except this. Complement. We are shading everything except this. It's as simple as that. Let's continue to here. This is very cool. A intersection B, right? And then the union. The union, you know, A union B. Everything in A, everything in B affect the intersection. Now, this is also here, right? So we have found this. We have found this already in the earlier example. Finding this also earlier example, right? So we add the union, and that is it. It's as simple as that. Now let's move on to the De Morgan's law. Write this thing down or take a screenshot, because this will be as a guide. So the first law is into A union B, or complement can be expressed as A complement intersection B complement. Then the other one, the opposite is also true for here. Into A intersection B or complement is expressed as what? A complement union B complement. That is it. So let's see this in practice. I'm rushing through, but the important thing is the examples or the explanation that I give is very, very important. If you get this, pause the video, assimilate the information, whatever I'm saying carefully, and you see that this is very, very easy. As maybe the first time you come across this will be very daunting, right? Very opaque, as if you can never understand. But if you take these steps that I'm giving you, you get it right. So now the basic one, which I know you already know, A union B, everything in A, everything in B affecting what? The intersection. Now we are looking at this. Now the complement means it's like whatever we saw in this, we are looking for the opposite of it. If you were shading everything here, by here we are seeing that everything complement, we are just shading the reverse of that. So look at it very carefully, the reverse of that. It's as simple as that. Now we said something about A complement. What did we say about A complement? Right? For A complement, we are shading everything in U and other sets except that particular set that we are talking about. That is what? For complement. We are shading everything in U and everything in other sets. So other set is B. Except what? A. So that is how it has been shaded. Now, the same thing is applicable when you're looking for the B complement. I hope you are getting the point. Now look at here. When you come here, we have A complement intersection B complement. This is a De Morgan property. So how do you remember this? You go back to go and look at that De Morgan rule, right? Now, this is the De Morgan rule. This is what we are given. So looking for the opposite will be this. And looking for this means you are looking for A union B, then you look for the complement. You share the opposite way. So this is why we have it. We have this here. So you get a point. It's very, very simple. Now the same thing comes here. This one is simple intersection. You have that. Now the opposite. If you were shading only here, now the reverse, we are leaving this out. It's as simple as that. So get one concept and you'll be good. Now you come here, A complement, B complement, you find that. Then you come here. This is also another De Morgan's law. Let's look at what it means. Now this is another De Morgan's law, right? A complement, U complement. This is what it means. And now when you have this, with the properties that we said, look for what? The bracket and look for the complement. So now we have this. So let's go and look at it. So we can see that this is it, all complement, and this is also expressed as this. See, so check the formulas once again. I'm short on the time. So this is the same expression. Look at it very carefully. So we'll see in the next one. Bye.